Hello students, and welcome to this calculus video. In this video, we're going to go over the 5 commandments of particle motion, and we're going to start doing some free response questions. So let's get started. So the first commandment is that if velocity is positive, the particle is moving to the right. One thing you want to keep in mind when we're talking about particle motion is, again, we're talking about the particle moving along the x-axis. So if velocity is positive, we know we're going to the right on the x-axis. Now, the opposite is also true. If velocity is negative, the particle is moving to the left on the x-axis. Now, in all of our other problems, we've only been talking about velocity so far, and you can see it in the first 2 commandments. But one thing we haven't talked about is speed. And so speed is velocity without direction. So velocity can be negative or positive, whereas speed can only be positive, the absolute value. So one thing that we want to keep in mind is that speed is increasing, we're getting faster when velocity and acceleration have the exact same sign, whether velocity and acceleration are both negative or whether velocity and acceleration are both positive. You can speed up in the negative direction or you can speed up in the positive direction. So then the other thing that we want to keep in mind about speed is that speed is decreasing when the velocity and acceleration have opposite signs. Velocity could be positive, acceleration might be negative, or the opposite might be true. So then that means that the speed is actually slowing down. And then finally, one thing that we want to keep in mind when we're talking about particle motion is about when velocity is 0. So if velocity is 0, then we're normally saying that the particle is stopped. However, if the acceleration is not 0, the particle is only momentarily stopped and is actually just changing direction. So if velocity is 0 and acceleration is 0, then you know that the particle is completely stopped, okay? And it's gonna be stopped there for however long another force is gonna act on it. But if velocity is 0 and then acceleration could be positive or negative, but a value, then you know that the particle is actually just momentarily switching from negative to positive or positive to negative. All right, so let's kind of use these commandments to talk about speed here in this question. So suppose the velocity of the particle is given by this function v of t. So keep in mind we're given velocity, okay? T is measured in minutes and v of t is measured in inches per minute. So we want to find the values of v of 3 and v prime of 3. Okay, and then we'll be able to describe what the speed of the particle is doing at 3 seconds. So let's find v of 3 first, because then that's just subbing in a value. So then 3 plus 2 and then 3 plus 4 squared, and we're gonna get here 245. Now keep in mind that we know exactly how v of t is measured. That's going to be inches per minute. So we'll put that down, inches per minute. So now we want to find v prime of 3, but we don't have v prime of t yet, so let's kind of find that. And one thing that I want to keep in mind is that v prime of t equals a prime of t, okay? Not a prime of t, just a of t. It means the acceleration, so let's go ahead and fix that. And we're going to need to use the product rule here. So I have the derivative of the first times the second, so that's going to be t plus 4 squared plus the first, which is t plus 2, times the derivative of the second, which is, we're going to need the chain rule, so times 2 t plus 4 times 1. All right, and I'm going to kind of leave it like that, and I'm just going to substitute in, right, we want to find v prime of 3, so if you substitute in 3 for all of those, that should come out to be 119. Now, again, we think about what's in your numerator and denominator is dy over dx, right? So we're going to get inches per minute. So that's going to be inches per minute squared. So then, well, what are we going to be able to say about the speed? So since v of 3 is greater than 0 and v prime of 3 is also positive, the particle is speeding up at t equals 3 minutes because they're both the exact same sign. That's all we need to say about what's happening at 3 for the values of v of 3 and v prime. So now we want to go into this next part on what intervals is the particle moving to the left, right, and then we also want to show our analysis. So let's think about this. We're moving to the left when the velocity is negative. We're moving to the right when the velocity is positive. So What we need to do is just figure out when is the velocity positive and negative, which is going to bring up a sign chart. So let me just think about v of t real quick. And as I'm looking at the function, when are we gonna get zeros? Well, we're gonna get zeros at t equals -2 and t equals -4. We're gonna get zeros there. But those actually aren't on the domain. Remember here that t is always going to be greater than or equal to 0 because time has to start at 0. So we're not going to take into account those negatives, and our sign chart is going to look, just like one thing. So let's see what the sign is the entire time from 0 to infinity. Well, I'm going to substitute in the value of 1 here. So I get 1 plus 2, that's going to be positive. And then 1 plus 4 squared, that's going to be positive. So all of this comes out to be positive. So over the entire domain for t greater than or equal to 0, we know that the particle is always moving to the right. Okay, and now let's get into the first of our 3 AP free response questions. This is a modified version from the 1998 AP Calculus exam, but we're going to be given some sort of graph over there, and we're also going to be given a table, and this is all related to velocity. Okay, so in our first question, it says, during what intervals of time is the acceleration of the car positive? So when is acceleration positive? Well, acceleration, so a of t, is greater than 0 when v of t is increasing. So I'd like to just get my thoughts down, and in fact, that's just like the justification that we're going to need to provide. So when is it happening? When is a of t greater than 0? Well, that's happening when this entire function is increasing. You can see it increasing pretty much this entire time from 0 to 35 and then 45 to 50. So that's going to be our answer, 0 to 35 and 45 to 50. So I like to start with the justification so I can keep my head straight as I'm going into this, because I'm not talking about where's it positive, because that velocity is positive everywhere. But I want to think about, okay, what am I given? What am I trying to find? And then how are those two things related? So now here in our next question in part B, we want to find the average acceleration of the car from 0 to 50. So think about when we were doing average acceleration earlier, we just want to find the rate of change of the velocity, right, over this time frame. So average acceleration is going to be equal to v of 0 minus v of 50 over 0 minus 50. So let's see what this comes out to be. I'm going to get negative 50 in my denominator, and then that's where this table is going to come in really useful, because over here in the table we have all of these values given to us. So v of 0 is 0, and then v of 50 is 72. So let's go ahead and write 0 minus 72. And if we simplify this just a bit, we get 72 over 50. But we do want to indicate units of measure. So let's look above and see what our units of measure are in. So in my numerator, I have feet per second. And then in my denominator, I have seconds. So then that's feet per second squared. That's going to be my units here. So feet per second squared. And then that's it. We're good to go. All right, a couple more here. So we want to find one approximation for the acceleration of the car at time t equals 40. And we want to show how we're getting it. So what we want here is we want to find the exact instantaneous acceleration here. Well, we can't find the instantaneous acceleration here because we don't have a derivative. But what we can do is use the points around it and find the average acceleration. And that could be a good approximation for the instantaneous acceleration at that point. So we're going to be using 35 and 45 seconds, and we're going to be using 81 and 60 for our velocity. So let's go ahead and write this down. So we'll say here that a of 40 is approximately equal to this average acceleration of v of 35 minus v of 45 over 35 minus 45. And I just want to keep in mind, just make a note here that this is v prime of 40. So they're the same thing that I'm finding. So let's go ahead and write down these values. These were 81 minus 60 over negative 10. And so all of it comes out to be, let's see, negative 21. No, that's not negative, that's positive 21 over -10. And we want to also think about, okay, what is the measurement here? And that's our final answer, right? I mean, I don't need to really simplify this anymore. In fact, at this point right here, I didn't even need to simplify it anymore. We just needed to throw down our units of measure. And so our units of measure, again, are going to be feet per second squared, because in my numerator, I have feet per second, and in my denominator, I have seconds. So now we want to answer this final question. Is the speed of the car increasing or decreasing at time t equals 40 seconds? So again, we want to think about what is A of 40 and what is V of 40. So let's look at the signs here. So A of 40 is, and we just want to think about the sign because that's -21/10. So that's going to be less than 0. That's going to be negative. And let's see, V of 40. If we look at V of 40, and we can just grab that from this chart right here, that's at 75. So that's a positive 75. So then that's going to be greater than 0. And so what happens when those are opposite signs? That means that the speed of the car is going to be decreasing. The reason for that is because V of 40 and V prime of 40 are opposite signs. All right, and that's going to be concluding this video here, this lesson. We have 2 more videos left in this lesson. Again, we're gonna just be going over 2 more free response questions. So go ahead and stay with me for 2 more videos. Keep practicing. See if you can actually do them on your own first and then come to the videos and see how you do. Of course, if you need any help understanding any of the content given in this video, please reach out to me. I'm Mr. Hernandez. This was Mr. Hernandez Teaches.